Uh, we are continuing chapter 2.3, special mathematical expectation. Now I'm going to the book here. Can you see the book?
Ji sir.
Uh, in the last class, we have seen how using the expectation we can find the mean and variance. I want to give you revise. The mean is known as mu, which is actually expectation of x, and the variance is defined as the sigma square, which is expectation of x square minus expectation of x whole square. These are the formula. But sometimes calculating the expectation is tough. Instead, moment generated function is easier. And the moment generated function mt is equal to expectation of e to e tx, and that can be found as some e to the tx fx. Now we'll try to understand how we can find the moment generated function. We can find the mean and variance by the moment generated function. Here you can see if we differentiate the moment generated function with respect to t, here the coefficient of t is x, right? Coefficient of t is what? X. Can you hear me?
Ji sir.
And since we are differentiating with respect to t, so fx is constant. This is constant. T is x is also constant, so x will come appear here like this. Also, if we differentiate the second time, there will be x square e to the tx fx. So if we differentiate r time, it will be x to the r e to the tx fx. Now, if we in here, if we input t equal to 0, then e to the tx is 1. So it will be x fx. It will what?
Sir, FF.
So which is expectation of x. So m dot 0 is expectation of x. That is, we can find the expectation by differentiating moment generated function. For the first time, we'll get expectation of x. Similarly, if we put here t equal to 0, we'll get x square fx, which is expectation of x squared. And so on, we can find up to this. Then, we know the mu is equal to expectation of x, but we got it m prime 0. Okay, first differentiate it, then put 0 to equal to 0. Similarly, the variance, now you can write the expression of x square minus expression of x whole square, that is m double prime 0 minus m prime 0 whole square. That is, instead the expectation, you can use the moment generated function to get the mean and variance. Do you understand? বুঝতে পেরেছো কি? হ্যালো?
Ji sir.
Okay. In the last class, we have found this is a geometric distribution. We have found the mean and mean using the expectation of this geometric distribution. Today, we'll find the mean and variance using the moment generating function. Using the
Sir, moment generating function.
generating function. Okay, this is the PMF, that is the probability mass function for geometric distribution. Q to the power x minus 1 p. Q to the power x minus 1 p. Then the moment generating function is e to the power tx, expression of e to the power tx, that is e to the power tx fx. Then you can see q to the power x minus 1 p. This can be written as q to the power x divided by q p. That is, we can write here p by q to the power x. Can you write it?
Yes,
লিখতে
sir.
পারেন?
এটা লিখতে পারি।
Okay, p by q to the power tx. But you can see q has the power x and e to the power t also has the power x, so they can be written within the bracket. Okay, then put the values x equal to 1, 2, 3, you will get this. Now this is an infinite geometric series. For the infinite geometric series, we know the first term divided by 1 minus the ratio. You can see this is increasing in the same ratio. Okay, then q cancel, you will get p to the t by 1 minus q to the t. That is the moment generating function for geometric distribution. This is the moment generating function for what?
Geometric distribution.
Geometric distribution. Now we have to check whether this is really moment generating function or not. How we can check? We'll put m0. What will put? m0. If we put m0, e to the t equal to 1, that is e to the 0 equal to 1. So p by 1 minus q, and we know this is what? So what's this? Okay, do you understand? কি বুঝতে পেরেছো?
জি স্যার।
Okay, now since this is the valid moment generator function, then we can find what? We can find the mean and variance, right? Mean and variance of the distribution by this. So how can we do this? I'm leaving this for you. Differentiate this in u by v method. First time, second time, then put here t equal to 0, you'll get this. Exactly what? 1 by p, what we get in last chapter. Then once again put m double prime 0, t, that is here, e to the t equal, e to the 0 equal to 1 here. So there's two terms, you get it. And mean equal to 1 by p, and put here the values of m double prime 0 minus m prime 0 whole square. After solving, we'll get it. That is, for a geometric distribution, the moment generating function is equal to q e to the t, sorry, p e to the t one minus q to the t. This is the moment generating function. Me equal to 1 by p, and sigma square equal to q by t square. These are the standard values. You cannot change them. They are always what? You have to talk with me. They are always hello. অলওয়েজ সেম, অলওয়েজ কি হবে? এগুলো চেঞ্জ করার কোনো সুযোগ তোমার নাই। নিউটন ডিস্ট্রিবিউশনের জন্য এগুলো অলওয়েজ একই থাকবে। বাট fortunately you haven't to derive them in exam, you have to just use them. That is, if we give you the moment geometry function, you have to find first p and q from here, then you have to use them for several options. I hope you can do. Now exercise. Why I'm not getting any response? Hello.
Yes, sir.
It's because you're probably having difficulty understanding.
Okay. Now exercise. In exercise, you have to do the maths 1, 2, 3, 4, then 8, 11, 16 in your syllabus or not. Let me have a check. 11, 17, and 19. These are the maths what we have to do. So let's start from number 1. Look at this. For the mean and variance of following distribution, discrete distributions, find the mean and variance. That is, for each of them, you have to find the expectation of x and expectation of x squared, then use the formula. Do you understand? Hello?
Yes, sir.
Very easy. I'm giving the instruction and want to give them homework. Just here, the probability, this is uniform distribution, so all of them have the same probability, and the x are given. So all the you have to find first the expectation of x. I think you know, for x equal to x of x. That is, each of x and its probability have to be multiplied and then adding. I think you know, right?
Yes, sir.
Then you have to do the expectation of x square, and that is sum of x square of x. Same thing, but now take x square instead of x. Then you have to write mu equal to expectation of x, sigma square equal to expectation of x square minus expectation of x whole square. There's the word from here, but here the probability directly given. Here also given only one event with the probability 1 because only it will be happen. So its expectation is 5, and its x square, that is expectation of x square will be 25. This is only 1, so Its expectation is itself, and its variance will be 0. You can calculate this. But for this, first you have to find the probabilities using these values. Then you have to apply them to here. Now number 2. I'll do A for you, and B will be homework. There are sort of disturbing elements here, but I ask you to not do them. You just follow what I am doing. You have to just follow what I am doing. Okay? বুঝতে পেরেছো?
Yes, sir.
আমি যা করবো এই যথেষ্ট। So let's come. It's slightly technical, not visual calculation here. So be careful. 2a. Here fx is 3 factorial x factorial 3 minus x factorial 1 by 4 to the power x 3 by 4 to the power 3 minus x. Now one thing, if you give the input in this directly, then it will be tough. So we'll minimize this. Actually, this is a 3. This is actually the formula for combination, right? And for this part, we can write 3 to the power 3 minus x divided by, you can see 4 here, 4 power is x, and here 3 minus x, so 4 cube. You understand?
Yes.
That is what? 3cx 3 to the power 3 minus x 64. Am I right?
Yes.
Yes.
Now we can put the value. I think it's now easier. You can use the calculator now, right?
Yes.
Now if we put 0, 3c0 is actually 1, and 3 cube is 27. So 1 into 27 is 27 by 64. Then p of x equal to 1. 3c1 is 3, but here now 3 square 9. So 1 second 27. Then x equal to 3c2 is also 3, but here only 3 to the power 1, so 9 by 64. Now 3c3 is 1, and 3 divided by 0 equal to 1. So all sort of things in our hand, right? Okay.
Yes, sir.
Now we have to find mu equal to expectation of x. How can I do this? Sum of x f x. The first entry is 0, has the probability of what? Second entry is 1, has the probability. Then the entry is 2, has the probability. Finally, the entry is 3, has the probability. So the result will, after the calculation, 48 by 64. Do you understand?
Yes, sir.
Now the expectation of x square. 0 square is 0. 1 square is 1. 2 square is 4. 3 square is 9. After calculation, you'll get 72 by 64. Okay.
Yes, sir.
Now they said to find expectation of x minus 1. Then using the linearity property, you can write expectation of x squared minus expectation of x. Then 72 by 64 minus 48 by 64. That is 24 by 64. And finally, they said sigma square can be written as, they said in this way, so we are writing in this way. But if we have to find the variance directly, we'll use expectation of x square minus expectation of x whole square. Oh, they will be capital. With their suggestion, we have to write this. So 24 by 64 plus 48 by 64 minus 48 by 64 whole square, and after the calculation you'll get 36 by 64. Okay.
Yes, sir.
Do you understand?
Yes, sir.
Now the next one. Number 3. Some quantities are given. Using those quantities, we have to find variance of x plus 4, mu, that is expectation of x, and sigma square, that is variance of x. So let's go. What we can do. First, we'll write what is given to us. Here given expression of x plus 4 is equal to 10, and variance of x plus 4 is what? I forget what given. Oh, sorry, expression of x plus 4 whole square 116. Okay. Now we have to use them to find other quantities. You can write, you can see x plus 4 equal to 10, but using the linearity condition, we can write here expectation of x plus 4 equal to 10. So what is expectation of x? 6, isn't it?
Yes, sir.
Yes, sir.
Now I can write here expectation of x square plus 8 expectation of 8x plus 16 is equal to 116. Then I can write expectation of x square plus 8 expectation of x plus 16 is equal to 116. Now put the values. We don't know what is the value of this. Plus 8 into 6 plus 16 is equal to 116. Then this is 48 plus 16 is 64. So 116 minus 64, 36, 16, 52. So expectation of x squared is 52. So both the expression of x and expectation of x squared in our hand. Am I right? Can you see?
Yes, sir.
Since they are in our hand, we can easily, what can we do? We can easily find mu. Mu is expectation of x is equal to 6. Variance of x. Vx is variance of x. We can write this sigma square is equal to expectation of x square minus expectation of x whole square. 52 minus 36 is equal to 16. And finally, variance of x plus 4. We know variance of ax plus b is equal to a square. That is, here the coefficient is 1. So 1 square variance of x. So 1 square is 116. Do you understand?
Yes, sir.
Easy math. Then go for number 4. Let mu and sigma square be denote the mean and variance of the random variable. Determine this and this. We have to determine those. Okay. Now for expectation of in chapter 3.3 we'll see that actually this is the standard variable. If x is any known variable, then x minus mu by sigma is a standard variable. We'll discuss more about the standard variable in chapter 3.3. Now sigma is constant, so we write sigma expectation of x minus mu 1 by sigma. Now you can write expectation of x minus mu is constant 1 by sigma mu minus mu equal to what? 0, alright? What's this?
Zero.
Hello? 0. Then expectation of x minus mu by sigma whole square is equal to you can write here sigma square 1 by sigma square is a constant since the square is present here. Then you can write should be written in this form. I think in question is like in this way, right? and within the bracket we have to square this, so it will x square minus 2 mu x plus mu square. Then you will see 1 by sigma square expectation of x square minus 2 mu expectation of x plus mu square. 1 by sigma square expectation of x square. Actually, this is another mu. So minus 2 mu square plus mu square. Then we'll find 1 by sigma square expectation of x square minus mu square. This is actually variance. So variance square by variance square. Variance by variance is equal to what? 1. This is what?
1.
1. Oh, one thing we'll consider, if we'll take let, in this chapter you'll get z equal to x minus mu by sigma. You got the expectation of z is equal to 0, and expectation of z square is what? Sorry. One. So what is mu? 0, right? Mu of z is 0, and variance of z is 1 minus 0 square is equal to 1. So if you convert to z, its mean is 0 and variance is what? 1.
1.
Mean 0, variance
1.
1. Eight homework. Just put the value, you get the probability, and using the probabilities you can get the mean, variance, standard deviations. Standard deviation is just positive square root of variance. Then number 11. Read the question and tell me what we have to do. Hello?
Yes, sir. So we have
Yes.
find the mean, variance, and PMF of x for this function.
Yes, this is the moment generative function. From the moment generative function, you have to find the mean, variance, and PMF. But how? Come forward. 11. Empty has given us 2 by 3, 2 by 3 plus 2 by 5 here, 1 by 5, 2 by 2t plus once again 2 by 5. It is a 3t. First we'll check is it the moment generative function or not. So we'll check m0. If you take m0 2 by 5 plus 1 by 5 plus 2 by 5, definitely 5 by 5, 1. So this is MGF guaranteed. Okay.
Yes, sir.
Now the next part, you can see the coefficient of t is 1. So probability of x equal to 1, have 2 by 5. Then here's the coefficient of t is 2. So x is 2 here, probability 1 by 5. Finally, here that's 3. So the probability of 3 is 2 by 5. Now, I have taught you a formula. If this is increasing, decreasing then increasing, it will have a certain formula. I have said, what is the formula? Fx is y extreme plus minus x extreme divided by m. According to this, the minimum value is here. What is the minimum value? What is the minimum value?
1 by 5.
So you have to consider 1. 5 is m. 5 is what?
M.
Plus minus. You can see from 1 both sides is increasing. Both sides ke দুদিকে বেড়ে যাচ্ছে না 2 and 2. So it will be what? It will be plus. And x, for which value this is minimum? For which value?
2.
2. That is the PMF. So one part is done. Okay.
Yes, sir.
Then the moment generality function. Mean variance এগুলো লাগবে এখন। How can we find the mean and variance? We first find m dot t. We'll get 2 by 5 e to the t. Then plus the coefficient will come. The coefficient will come 2 into 1 equal to 2 by 5. I think you can differentiate this. 2 by 5 e to the 2t plus here 3 into 2 equal to 6. 6 by 5 e to the 3t. So m dot 0 2 by 5 plus 2 by 5 plus 6 by 5 10 by 5 equal to 2. Okay. Then m double prime t. Here 2 by 5 e to the t plus 4 by 5 e to the 2t plus 18 by 5 e to the 3t. Then m double prime 0 2 by 5 4 by 5 18 by 5. What will happen? 24 by 5, right?
Yes, sir.
So the mean equal to m dot 0 is equal to 2 and variance is m double dot 0 24 by 5 minus m dot 0 whole square 2 square. So 25 by 5 minus 4, so 4 by 5. Then the standard deviation is this 4 by 5. 2 by root 5. That is the answer. I think you can understand it easily. Okay.
Okay, sir.
Then 17. We will leave 17 1 because its PMF so tough. We are not intended to find the PMF here. Instead, we will solve B, C. Okay, since we are not getting PMF, we cannot do this. We will only find what? B and C. Okay,
Yes,
I want to give this homework because exactly what I have done in number 11. First, you have to show m0 equal to 1, then differentiate 2 times, put 0 there, then you can find mean and variance. What exactly I have done in 11. Okay,
Yes.
just a minute. Okay, now number 19. Actually, number 19 there is an error. That is, this is not correct. Since they have said the inputs will be 1, 2, 3, 4, 5, but here they shows it will be 0, but 0 is not in our set. Also, 4 is not included. That is, this is not correct. Do you understand? Hello?
Yes, sir.
They said that we have to find the mean and variance, find the probabilities, and then draw the histogram of the PMF. So let's go. Actually, this probability mass function number 19, it will be mt is equal to 44 by 120 e to the t plus 45 by 120 e to the 2t, 20 by 120 e to the 3t plus 10 by 120 e to the 4t plus 1 by 120 e to the 5t. Wait, it's gone. Okay. First, we have to check whether M0 is 1 or not. So M0 is 44 by 120 plus 45 by 120 plus 20 by 120 plus 10 by 120. Let's have a check whether the total of the numerators is 120 and this is 1. Okay. So it's correct what we have taken. Okay, বুঝতে পারছো?
Yes, sir.
Then we have to proceed to find the moment generated function m dot t is equal to, if you differentiate this, I think you can differentiate them all of them. Here differentiate this 1, 2 will be multiplied here, 3 will be multiplied there, 4 will be there, 5 will be there. So you'll get 44 by 120 e to the t plus 90 by 120 e to the 2t, 60 by 120 e to the 3t, 40 by 120 e to the 4t plus 5 by 120 e to the 5t. And if you put m equal to 0, you'll get 44 by 120 plus 90 by 120 and so on. And after adding them, you'll get 239 by 120. It's your work checking this. Then differentiate once again m double prime 0. We'll get 44 by 120 e to the t plus 180 by 120 e to the 2t plus 180 by 120 e to the 3t plus 160 by 120 e to the 4t plus 25 by 120 e to the 5t. Then once again, if you put t equal to 0, then the exponential part will be 1. It will be t. Then m dot 0 will be 589 by 120. Then mu equal to m dot 0 is equal to 239 by 120 and variance equal to m double prime 0 is equal to 589 by 120 minus 239 by 120. After the total calculation, you'll get 13559 by 14400. If you feel difficulty, you can use a decimal. তোমার কাছে সমস্যা মনে হলে তুমি ডেসিমাল সাইন ইউজ করতে পারো। বুঝতে পেরেছো?
Sir.
যেটা তোমার সুবিধা হয়। দেন এখানে পিএমএফ বের করতে বলেছে, পিএমএফ গুলো। বাট একটা জিনিস একটু দেখো, এখানে they are totally scattered. You cannot get any relation in two successive quantities. 44, then 45 increased by 1, then decreased by 25, then decreased by 10, then decreased by 9. Is there any certain form? Can you construct any rule there? রুল কনস্ট্রাক্ট করতে পারবা এখানে? If they cannot be constructed in a certain rule, then they are called scattered probabilities. And in this situation, we can write a PMF using piecewise function using what? Fx is 44 by 120 for x equal to 1, 45 by 120 for x equal to 2, 20 by 120 for x equal to 3, 10 by 120 for x equal to 4, and 1 by 120 for x equal to 5. That is the formula. Then you can sketch the line graph using those. Sorry, not line graph, histogram. Say first one is 44 for 1, 2, 3, 4, 5. Let us choose. So say the first one is 44. Second was 45, slightly higher, right? I'm sketching approximately. Then 20. Then 10. Then 1. This is the approximate graph. Okay. বুঝতে পারছো?
Yes, sir.
जी sir.
This is 1, 2, 3, 4, 5 in the middle. Okay. By this chapter is completed. Now you can ask me if you have any question. You have 2 minutes to make your question. Hello.
Yes.
Yes, sir.
If there is no problem, I am going to introduce the next chapter.
So next chapter.
The binomial distribution. Now, what is the binomial distribution? This is a burning question. What is the binomial distribution? There is binomial. There is two types of outcomes in your hand. How many types? Two types of outcomes. Though in an event there are so many outcomes, you have to classify them. Some of them in your favor, and some of them in not in your favor. So they are classified in two types. So say there are many elements here. You take some of them in here and some of them here. Those elements you are taking in favor, you are taking non-favor. They have in your favored event outcomes. They have total probability p, and they have total probability what? Q, where p plus q equal to 1. You understand? P plus q equal to what? 1.
1.
Now, say in p plus q equal to 1, you have trialed n times. You have trialed n times where you are expected or you want x times success out of n time trial. You want how many success?
X time.
X times success. In this case, they can be arranged in NCX combination. So x times success have the probability of success q to the power x with q to the power n minus x. This is called the binomial distribution. This is called what? Binomial distribution. Okay. Now, it will be binomial distribution if it follows some rules. Number one, these n trials are independent. That is, the first trial, the second trial not depends on the first trial. Also, the third trial not depends on the first and second trial. That is, the trials are totally independent. If you trial 100 times, all the trials can be done independently. Do you understand?
Yes, sir.
This is the first one. Now, the second one, though you are trialing many times, P and Q remain same. They will not be changed. That is, if you start at a time with the probability of success is 0.4, probability of failure is 0.6, it will remain the same till the last. শেষ পর্যন্ত কি থাকবে probability? Same থাকবে না?
Same type.
If n is 1, that is you can trial only one time. Usually here x equal to 0, 1, 2 up to n. Why 0? That is, it's possible you cannot get any success. এমন তো হতে পারে তুমি কোনো সাকসেস পাবা না, হতে পারে না?
Yes, sir.
So it's 0 to n. তুমি সাকসেস নাও পেতে পারো, সবগুলো পেতে পারো, এর ভিতরে যে কোনো একটা. If n is 1, yes. Any question? No. If n is 1, that is you're allowed to trial only how many times? One time. How many times?
1 time.
One time. Then it will be fx. 1c x is now 1. So p to the power x, q to the power 1 minus x. In this situation, x is 0 or 1. If 0, you fail. If 1, you Successful.
Success.
This is called Bernoulli trial. This is called what? Bernoulli trial.
Bernoulli trial.
That is, in a binomial distribution, the individual trials are called Bernoulli trial. That is, একটা binomial distribution যদি তোমাকে দেওয়া হয় তাহলে সেখানের মধ্যে ইন্ডিভিজুয়াল ট্রায়াল গুলোকে কি বলবো? বার্নৌলি ট্রায়াল বলবো। কি বলবো? বার্নৌলি ট্রায়াল। এক্সাম্পল 1 2 3 এগুলো তোমরা 1 2 3 4 এগুলো নিজেরা দেখবা। যেটা আমি ডিরাইভ করছি মাত্র সেটা হচ্ছে এই। এখন এখানে যেটা আমি বলেছিলাম, as per I have said, the Bernoulli experiment is performed n times. The n is constant. Trials are independent, and the probability of success on each trial is constant. That is, cannot be changed. And the random variable x equal to the number of success. Please mute your mic. Please. Sometimes a Bernoulli trial can be written as B and P. Here, B for Bernoulli, N for total trial, P for success. Like they have written B12 1 by 4. That is this binomial distribution. They can trial 12 times with probability of success is 1 by 4. Like here, an example is given. In the instant lottery, 20% winning ticket. 20% winning ticket. Don't consider this P directly. If winning is target, then this is P. But if losing is target, then this is Q. So you have to read the total question. If x equal to the number of winning, so P is now 0.2, 20%, 0.2. Q is 1 minus this, so 0.8. And they have said among 8 winning the tickets among n equal to 8 that are purchased, তার মানে 8টা টিকিট কিনছে। কয়টা? 8 tickets. Then the probability of purchasing 2 winning ticket, that is probability of 2 success, is HC2 P to the power, that is 0.2 to the power 2, 0.8 to the power 6. That is the probability of getting 2 winning ticket out of 8. Similarly, let the number of x of seeds germinate n equal to 10, satisfying this. Satisfying this means n equal to 10 and p equal to what? 0.8. Then the PMF, that the total probability will be what? PMF 10cx, 0.8 to the power x, 0.8 to the power 10 minus x. Then they asked, what's mean by this? X less than equal 8, that is at most 8 seeds can be germinate. At most. Less than equal means at most 8 seeds will germinate. But at most means less than equal 8. So x equal to 0, x equal to 1, 2, 3, 4, 5, 6, 8. It's tough, right?
Yes, sir.
So we are using the complement. That is the 9 and 10 not in our hand. Just subtract x equal to 9 and x equal to 10 from 1, you will get the desired result. Put here x equal to 9 and x equal to 10. X equal to 9. 10c9 is 10. 0.8 to the power 9, 0.2 to the power 1, and 10c10 is 1. So 1 has not been written. 0.8 to the power 10 0.2 to the power 0, that is 1. That is the result. You can see complement used once again here. Okay.
Yes, sir.
So you have to practice number 5, number 7. Also try this. Here up to 6. So you have to subtract 7, 8, 9, 10. This is what CDF, cumulative distributed function. Same thing. Already you have done this. Up to 6. So this is cumulative, right?
Yes, sir.
So if we say find the probability, the x up to x, this is means p of x. This is called a CDF. That is cumulative. যোগ করে আসছে না?
Yes, sir.
এই যে দেখাচ্ছে এখানে। টোটাল প্রবাবিলিটি কনসেপ্ট আনলো না কেন এখানে? You can see here, Layton chickens are raised in laying egg, P is 0.5. Probability that newly has chick is female. Like 50% হচ্ছে কি কহে? Female. That is, the rest of the 50% will be male. Assuming independence, be careful. The difference between the hypergeometric and binomial, just the independence. Hypergeometric distribution is not independent, whereas the binomial distribution is independent trial to trial. Let x equal to the number of female chicks out of 10 newly hatched chicks selected at random. The distribution is B10.5. That is 10 trial, 10 has chicken with the probability of getting female 0.5. That is, we can write fx is what? 10 c
10 C,
x
5, 10
0.5
CX,
x 0.5 10 minus x. This is very fun. That is 10 cx 0.5 to the power 10. Just put here. Then the probability of 5 or fewer, that is at most 5, is this. Just put here 0, 1, 2, 3, 4, 5 and then add them. This is actually CDF. This is what?
CDF.
You can write here 5. Okay. Also, if exactly 6 female chicken are required, then 10c6 up to the power 6, up to the power 4, actually up to the power 10. Don't do this. Use calculator to find this directly. And if we get we want at least 6 female, at least, that is more than 6 more than equal 6, just subtract 1 minus this, because this is in our hand. This example they made in very tough way. I'm ignoring this. I'll make the maths in different way, so I ask you to ignore this. I'll tell the basic thing to you. Say B and P. This is the binomial distribution with n trial and rate of success P. If we want here, if we want x success, how many success?
X success.
Its complement will be B and Q, and if this y success is this is complement. If B and P is a binomial distribution, B and Q another binomial distribution, but they are complement. They are what?
Complement.
Complement. Here y equal to n minus x. The relation is what?
N minus X.
Just try to understand this. They made this in very hard way. Just leave it. Just leave this. Okay, in the next class we will start from here. Okay, there are some proof required. I have time, so I think no, I have time, but I haven't enough time.
जी सर
10
escape
minutes,
हो जाएंगे
right? 10 minutes is not enough to show them. Okay. So just study this complementary issue. I'm going to take the attendance.